All right, we're back with the last live session of the day. Obviously, there's tons of stuff tomorrow as well. I might recap that. I don't know if I have the paper. They might get it to me if I'm lucky. We're here with our last guest, Shweta. Gupta, how are you, my friend?
I'm doing great.
Fantastic. Yes. So tell us a little bit about New Zealand. Is this the first time you're here?
Yes, it's the first time, and I came here on Monday. So the weather is nice and sometimes not nice, but I'm getting used to that. I'm looking forward to see more of it.
Fantastic. Yes. So tell us a little bit about the talks that you've given. Let's start with, I know you're doing stuff with IoT and stuff with data. Let's start with IoT for those that are interested in what it is and how they can sort of benefit from it.
Sure. So actually, when I think of IoT, first thing that comes to my mind is WALL-E, the movie, where there's a scene where the captain comes up with a manual and he says, "Manual, read me." Manual read, and he's surprised that he's supposed to open it up.
Right.
That's what IoT is going to be
Nice.
for us, right? So where things are going to be intelligent, they're going to help us do stuff. And my talk was about building such Internet of Things systems. It requires, so it's nice to play with Raspberry Pis, but when you're actually building a production scale systems, what are the things that you have to take care about? The scale and the hardware and the costs, because you have to, these are so intermingled, and it's a very complex system.
So if someone is building like an IoT system, obviously they're going to start with sort of something like an IoT, a Raspberry Pi, for example, or some Intel Galileo, for example.
Right.
Is that, but that's not what's going to eventually end up
Absolutely.
to being the product. So tell me about that evolution from sort of the prototypes all the way down to the, tell me about that gap, because I have no idea how you get from that to an actual product.
So to be honest, when you start with a Raspberry Pi and the prototype basically is to ensure that your business idea works, or it's going to solve the problem.
Right.
And then adding scale to it, you literally start from scratch, because you start with identifying what's the right hardware for me. You know, you have to take care of connectivity issue or connectivity points aspects. What's the cost aspect, because what's the business value add from it, and the scale aspect. For example, in my talk I was talking about monitoring 10 campuses for temperatures, and we did a calculation. We said we need 750,000 sensors.
Wow.
Yeah, so that's the scale we are talking about.
And that's not, you can't, I mean, for $35 times 750,000, all of a sudden that's not logical at all.
Absolutely. So you have to work with the right vendors, right set of experts who can really, like, we worked with a startup that brought down their cost to $2 by building their own microcontroller.
I see.
So there is so whenever the scale aspect comes into place, you start thinking about the costs, and you also start thinking about what business value is going to bring.
So that's cool, but I have my Raspberry Pi 3. I prove that this is working. I know that it works and it sends the data to the right place and everything happens. But now I need to sort of productize it. Do I have to build my own chip? Is that what I have to do? Do I go to someone else and say, hey, we need you to build this at scale? What are my options?
So I would divide the problem into two. One is the hardware and one is the backend.
Got it.
Right? So for hardware, I would go to a vendor, or I would go to an expert. If I'm an expert, I might end up building my own chip, but most likely you go to a vendor. There are a lot of vendors who build microcontrollers. Work closely with them to identify because most of the times the hardware has a lot of features that you don't want to use, a very specific business application.
Right.
So I might end up, and if I'm working at large scale, working with them and coming up with my exact specification. And at the back end, I would probably leverage a lot of what I did in my pilot, because my back end typically, and hopefully we all embrace cloud.
Sure.
Like we have platforms like Azure IoT Hub, and which are just ready to go and can scale pretty remarkably. So I could relook at reusing my backend, look at the architecture, and make sure it's scaled for my at least a year's requirement, and can handle that.
So the thing about it is, like, and I like that we sort of switched to the back end, talking about the back end, because you're saying that the back end is probably mostly reusable, but the scale of data from 750,000 devices has got to be ridiculous.
Absolutely.
How do you manage sort of that level of data, what do you do with that data? How do you analyze that data? I'm guessing there has to be some kind of architecture that you set up. What do you suggest?
So, so we all follow the Lambda. I mean, that's the Lambda architecture where you have the data stream coming into a hot path and a cold path. That's mostly fits almost all IoT scenarios. So, so the data that's coming in, you probably need to do some near real-time processing, like you wanted to create alerts or update a live dashboard or send someone information, and plus you keep storing that data in cheap but reliable storage.
Of course.
Like, and then you have applications that could like have machine learning patterns that actually use that rich data to build accurate models and predict stuff. So that's what I would typically do.
So talking about the Lambda architecture, because this is an interesting thing. I've heard about it before. You mentioned hot path and cold path. You mentioned near real-time sort of analysis, and then you mentioned sort of storing your data in cheap sort of data storage. Tell me more. Which one's the hot path? Which one's the cold path? Let's start with hot path.
Okay.
And tell me, how do you analyze that volume of data near real time?
So, if I'm given a choice for the hot paths, I typically would use say Stream Analytics, because for me it's one of my favorite products.
Sure.
It's so simple that it lets you write a simple SQL statement and actually even complex statements that can that lets you focus on the conditions.
Got it.
You can check conditions, you can send the output to multiple outputs, you can push it to a Power BI, or you can push it to an event hub that can later be processed. So a hot path, I would use that as a technology, or I would use Spark on HD Insight cluster, because if it's, for example, if I have to analyze Twitter feeds, which is coming like 100,000 messages per second, and if I want to, I wouldn't want to analyze everything, but let's say I want to, I can with Spark, and I can do natural language processing algorithms on it, which instantly give me analysis, power up graphs that you've launched a scheme, or how's this product doing, it's going up or going down.
So the hot path then is the near real time stuff.
Yes.
So in the Lambda architecture, which is really clever, I like how you sort of separated these things. The hot path is when you want to look at stuff in real time. So you might have 750,000 sensors, and if the temperature is off in a room, you want to know about that right away.
Yes.
Is that would that be a hot path application?
Yes.
Awesome.
So I would want to know instantly or as soon as possible that the temperature is above or below, or maybe if a sensor is not working, there's recording not coming for a particular sensor. That becomes my hot path.
I see. So now tell me a little bit more about the cold path. What does it mean to be in the cold path in the Lambda architecture?
So taking this example forward, so let's say I have 750,000 sensors sending data every 10 minutes. I'm actually storing, if I store all that data and I combine it with, let's say I'm monitoring a facility, an office, I combine it with Outlook calendars to get the meeting information, how many people are attending meetings and how many people, or attendance management systems. Combine it with the weather patterns, combine it with the weather API, get weather data, and actually I can predict what should be the ideal temperature for that building for say tomorrow. So it kinds of reduces people manually triggering the increase and decrease in temperatures and probably making it more energy efficient.
I see. So what you're saying is that you're looking at the old data that you've been storing this whole time. You build predictive models that help you predict the future, so that you can sort of have a good environment when in the meeting. So when people are looking at hot and cold path, we're talking about cold path. What are some of the technologies in the cold path that people should look at for storage and for analysis?
So for storage, so even in my talk I said that we should definitely embrace cloud, because it provides extremely cheap, reliable storage. For example, blob storage, it's got three redundant copies even in a locally redundant, and then not to mention you have a JRS with 6 copies. So I would use blob storage to store all that data, and then I would build machine learning, use machine learning to build. I'm not a data scientist, but I've worked on some of the experiments. It's pretty intuitive and fast. It exposes APIs and batch services, which lets you consume. And I would probably use PaaS services like functions to get pull data, or ADF to pull data from attendance systems.
Got it.
And pull all the data on cloud, and then run those models on it.
So the cold path is more of a thing that you use for analyzing your data, historical data.
Yes.
And the hot path is more of a, we want to react right away
Right
to some
now,
changes.
yes.
So how can someone get started with all of this goodness? I mean, it feels like we started with IoT, we talked just sort of about the data architecture of these things. How does someone get started? Do we have something, a paper or a website, or what can we do to get started?
So to be honest, there is a lot of information on, we have a lot of GitHub samples, and in fact, I'm just going to make that available. The same demo that I showed, I created a service fabric application.
Awesome.
Which simulates temperatures, and you can scale it to a 30-node cluster to get like really large scale data coming in, and then all that data passes through an IoT hub, which and we've also added some deaggregation and compression, decompression to it, and it splits the data into hot and cold. That sends the data out through Stream Analytics into Power BI and one into. So they can just, there is a lot of such information. They can just have ARM templates, go and just deploy and test it out by themselves.
So you mentioned a product that maybe we haven't talked about too much. You mentioned mentioned a little bit about Azure Service Fabric. What is that?
So, Service Fabric is actually one of our most sturdy products, I would call, because a lot of our services work on it.
Sure.
It's a microservices fabric. It lets you create several. It lets you build large-scale applications.
Got it.
Right. So you have small. You have it. It lets you scale specific modules to a large extent, and it provides the runtime. It manages it for you. So.
This is awesome. Yeah. So how do you like all this art? There's so much to look at when it comes
Absolutely.
to data. What do you think about it? What do you think about the future of Azure and the future of applications that use data?
For me, one thing is for sure that it's just going to be huge. It's going to be really huge, and Azure is built to cater to that. And what I really like is the fact that it's all managed services.
Sure.
I don't have to worry about it. You know, I can always have virtual machines, but I end up managing them.
Yeah.
And when the data goes in petabytes, I really don't want to manage that. So
that's awesome. Well, thanks so much for spending some time with us. Tomorrow, we have a full, well, it looks like a half lineup of stuff. We're going to have the kickoff with Rick and Amanda Rowland. Pretty excited about that. We also have a number of sessions that you don't want to miss. Make sure you stay tuned for the final day of Microsoft Ignite NZ. My name is Seth Juarez. This is Channel 9 Live, direct from New Zealand. We will see you, I hope, tomorrow.